Hello and welcome to day 4 of the 2026 HURREVAC training webinar series. This is our last day and we are on the topic of evacuation timing features. My name is John Boyer from Sea Island Software, the contractor that works on HURREVAC, and today's presenter, I invite Franny Bowie from the U.S. Army Corps of Engineers to join us here and take over the presentation. Good to have you again, Franny.
Thanks, John. Thanks everyone again for sticking it out. We are on day 4. We are so grateful that you are able to join us today. Just to recap, on day 1, we heard from the National Hurricane Center, introduction to the HURREVAC workspace. Day 2 was about wind. Day 3 was about storm surge and flooding. And today, we're going to put all of that information together, leveraging all of the training that we've received to date, but we're going to take it from an operational lens. As mentioned earlier this week, you all learned about the National Hurricane Program and several of its products and services. We heard from the respective offices about the forecast products and storm surge modeling. The other NHP product are the hurricane evacuation studies. So the products in that first column are then compiled and displayed in HURREVAC. The other thing I wanted to mention, and just again, give everyone a big props, is that training is another huge service that we provide as part of the NHP. And we, again, are so grateful for you to be able to join us today. Okay, next slide, let's dig into the hurricane evacuation process. So this graphic shows what the full hurricane evacuation study process is. This is really an overview. I'm going to touch on each of these analyses in the subsequent slides. Really, the first step is where we develop a plan of study, trying to better understand what your needs are. This is generally coordinated at the state level and with contacts from the Interagency Coordinating Committee on Hurricanes. You can also reach out to the FEMA or Army Corps program offices, the FEMA Regional Hurricane Program Manager. That was the map and contact list from day 1 of this training for discussion or for more information. So as part of that initial discussion, a lot of it is about figuring out what you, again, actually need. After the study kickoff, the major players in the decision-making we're expected to have some training on what these hazards and what this study is. We've talked briefly about them this entire week, but we also wanted to recognize that FEMA's National Disaster NDMU puts on these courses to also provide information and training to emergency managers. As we progress, we go through the 5 different hurricane evacuation study processes: the hazards analysis, the vulnerability analysis, the behavioral analysis, shelter analysis, and finally the transportation analysis. Even though this graphic seems very linear, there are certainly connections all over the place amongst the different analyses. And so at times you may be working on multiple aspects of each of these analyses in order to conduct the full hurricane evacuation study. The last thing I'll mention is that this is very much a multi-year type of process. It is close coordination between FEMA, the Corps, state and local emergency managers, and what makes these types of studies really actionable is input from you all and getting an understanding, again, of the needs that you have. At the end of the study, after all of this information is compiled, that's really where the deliverables are presented, the data is provided, a big report comes out, and we have final briefings with different stakeholders or different groups within those stakeholders. And the idea is that that would then build upon creating exercises and implementation for these studies. Some of the hurricane evacuation studies are state run. So there are some states within the jurisdiction of the National Hurricane Program that choose to kind of manage and organize their own study. A lot of the other studies, however, are, again, through FEMA and the Army Corps of Engineers to make sure that, we're able to, produce similar products. The hazards analysis is the first component of the HES. Primarily, we're looking at storm surge threat. As we learned yesterday through the National Hurricane Center slosh modeling, we talked a bit about moms and meows. We also have to understand kind of the inundation that comes from that slosh model. And, again, as we discussed the other day, it does depend on the direction and intensity and the depth of water shown above ground. If you need to review how to access the moms and meows, you can refer to the recording from yesterday, or if we have time later today. Instead of looking only at the maximum of maximum water depths for a set category of storm, the teams are looking at an equivalent storm surge risk from various storm scenarios for each of the counties in the study area. The intent of this methodology is to provide emergency managers and planners with a more focused look into the effects of storm intensity and direction in order to enhance your emergency planning. So, for example, in that first graphic for Jackson County, the direction of storm surge, or the direction of the storm, can majorly differ how much flooding an area could experience. So this example here shows that when a Cat 3 direction heading north-northwest has a greater maximum inundation depth as one with the northeast approach for a Cat 5. And so these types of groupings and analyses are done for each county within a study area, for each direction, for each different category of storm. We also noted yesterday about freshwater flooding as a threat. So in addition to looking at storm surge, we also leveraged FEMA flood insurance rate maps to examine potential hazards. Other threats that are considered include wind threat from maximum envelopes of wind, again, related to hurricane-related risk. The other thing I'll mention is that, if there are specific hazards that may be very specific to your region, that's, again, part of the discussion that we have during the hazards analysis. The next analysis is the vulnerability analysis. So that's really the second component. The graphic on the left is, again, one of the snapshots from slosh modeling showing storm surge impacts. And the idea is that now that we have an understanding of how far, what the extent and the depth of surge is, we can get a better understanding of what's actually vulnerable to storm surge and what's actually vulnerable to flooding. So these storm surge impacts are mapped, and then we coordinate with state and local emergency managers to draw the evacuation zones. So typically we do a first pass, we have a big meeting, we present this information and resources and results, and we listen to you, and we try to understand what is driving some of the decisions that you need to make when you're developing and calling an evacuation zone. So the idea is that overlaying things such as land use, overlaying things such as commercial or important structures, streets that may be flooded during a flash flood or a storm event, that helps us to better understand where there are potential risks that are not necessarily captured with just a storm surge map. So then there's iterations, and we go back and forth. And we hone in and create these evacuation zones. So then these evacuation zones are then also overlaid with critical infrastructure so that you and the departments within your jurisdiction may understand what infrastructure is at risk, what infrastructure is in an evacuation zone. The same thing is completed when looking at total population as well. And so for this instance, we're looking at a very populated part of the US. And so getting an understanding of how many people live in zone 1, how many people live in zone 2. If you had to call an evacuation that had zone 1 through 5, how many thousands or millions of people might be impacted by that order? The third phase of the hurricane evacuation study is the behavioral analysis. And this is really a means to determine assumptions of how people might react to an evacuation. The results that come out of the behavioral analysis include evacuation participation rate. So how many people will listen to you and heed the call of an evacuation and leave the area if they are threatened? How long might it take for an evacuating population to leave their home once an evacuation is ordered? That would be the response time. Where are people going? Are they going much farther inland? That would be destination. And then also, are they using public shelters? How many people are actually seeking shelter of the people that are evacuating? And how many vehicles and people per vehicle will the average household use? So it's a combination of looking at data and at times also behavioral surveys. So the graphic on the left shows some telemetry data from a recent event, and you'll see that the y-axis is net vehicle departures. If it is blue above 0, that means that people are leaving a specific area. In the red bars is when people are returning to that specific area. So the days leading up to this event, you see people entering and leaving as they're going to work or coming home. For this example here, you'll see that the evacuation order was issued at 9 o'clock. Some people left early in the morning, and then there's a big spike of departures and not that many return trips for this specific area. When the storm made landfall, you'll see that there's not much net vehicle movement, but that soon thereafter, a lot of people are returning back to the area. And then you're again seeing this kind of like daily pattern again. So that again is one example. We're trending a little bit away from phone surveys that take a lot of effort. Some people don't pick up the phone anymore, but using telemetry data or an anonymized data in order to get a better understanding of people's actual behavior. The figure on the right is from a recent study where this was also done via a survey to determine where people would be going or where they did go during Hurricane Harvey as part of their evacuation and where really their destinations. I would say that a lot of the behavioral information is not necessarily done in a vacuum. And so one of the things that we've certainly been pushing is leaning on academic surveys, doing meta-analysis of the data that are out there to, again, get a better understanding of how people are reacting to these orders. The fourth phase of hurricane evacuation studies is the development of the shelter analysis. And really, this again is a close coordination between the project delivery team, either FEMA and the Corps of Engineers, and with the state and local emergency managers. The idea is to identify different shelter locations, to understand if those shelter where they are, if there's any specific vulnerabilities, and to use information from the behavioral analysis to determine what is the demand. And so when comparing how many people might use a shelter and what the existing shelter capacity is there a surplus or a deficit of shelter spaces? So again, this is just information. It is, a snapshot in time. So certainly things change, but at least it gives a baseline of where shelters could be leveraged. The final phase of the hurricane evacuation study is the transportation analysis. So the transportation analysis is where the evacuation clearance times are developed for various evacuation scenarios. We model a number of different scenarios that the state and counties ask for or coordinate with using transportation models. An example of the type of transportation model that has been recently used is called real-time evacuation planning model, otherwise known as Route PM. Other transportation models are used. There are, other acceptable means by which these clearance times are being calculated. But the idea is that this evacuation clearance time gives someone like an emergency manager an idea of how long it will take once an evacuation order is ordered for everyone to get to a point of safety. The different scenarios that are created account for which evacuation zones are evacuating. What is the participation rate? So are we modeling something that is conservatively high, like 100% of the people are evacuating, or something like where only 5 or 10% of the people are evacuating? And I'll also note that each hurricane evacuation study is unique and special. And so I certainly encourage you to understand and look into the documentation related to the HESs so that you understand what went into the actual scenarios. So the population in those evacuation zones are really the ones that are responding to the call. Based on the behavioral analysis, it's determining where they are going, which roadway network that they are using. So in the graphic in the middle, you'll see for the state of Delaware, anything that is green is a roadway that was being leveraged as part of that specific scenario. A number of other analyses and variables are included in the transportation analysis. And the idea is that you go through all of the steps as part of the hurricane evacuation study, create these up to 200 or 300 different scenarios given all of the different variables, and come up with this big table of all the different what if analyses that could happen. That is then summarized and then integrated into HURREVAC. So we'll dig into that a little bit more, in later on this afternoon in terms of how to access and what to look for in terms of that information. So I'm going to talk about a little bit about how some of those decisions or calculations are done, and then we can certainly turn it back over to John for some additional demonstrations. So I sort of touched on this, but how does one actually calculate an evacuation start time? So one of the first things would be to understand the hazards and what the storm forecast is coming from the National Hurricane Center. One of the outcomes of that is to look at the arrival time of tropical storm force winds, which in most cases is the first hazard that would impact your area of interest. It's not always the case, but it sometimes is the first hazard. From the hurricane evacuation study, there are already predetermined evacuation zones and those scenarios that I mentioned. So each scenario has a corresponding clearance time, and that clearance time will tell you how long it will take, again, to evacuate a given population under a certain scenario. Taking the arrival of hazards, in this case, the arrival of tropical storm force winds, and backing out the clearance time would give you the evacuation start time. Okay, so the next, for example, if NHC issues a forecast and it says the arrival time for your location for tropical storm force winds is 8 o'clock on Saturday, and based on the different variables and the category of storm and other information that you as the decision maker are looking at. The clearance time for that specific scenario would be, say, 36 hours. And so in order for you to start an evacuation, you would need to have that started by 8 o'clock on Friday morning. There are a lot of nuances and decisions that need to be made. And we're hoping that HURREVAC and this training this week will help you make those decisions. I think that's it for me. Thank you again for taking the time out of your busy schedule to meet with us and to learn more about the hurricane evacuation study process and about HURREVAC.
And we do have plenty of time for our HURREVAC demo today. So before we get into it, I want to outline our goals. We're going to make sure you know where to access the HES documents for your area. You'll see how to map evacuation zones and compare those zones to the storm surge layers we saw yesterday. You're going to combine clearance times with forecast data to calculate an evacuation start time. We're also going to show you, for example, you may have a role in an agency where you're not involved with clearance times and population evacuation, but you have other protective actions you need to do before a hurricane arrives. HURREVAC has you covered. There's a way for you to put your own custom timeline actions in, still build decision support that isn't related to zones or clearance times. And we'll show you how to do that. And we're also going to compare and contrast what it looks like to get these results from the evacuation timing report versus a map-based method called timing arcs. And our intent as we go through the next 90 minutes is also to review a lot of what we did earlier in the week. We've got a little bit of review. I like this graphic to put together all of the advisory products we talked about on Tuesday and on Wednesday related to wind and storm surge, and just remind you all in one glance when to be checking in HURREVAC to see the latest and greatest. Reminder on advisories. The National Hurricane Center and CPHC issue main advisories at 6-hour intervals. In Eastern Daylight Time, those are at 5 and 11, and also in Hawaiian Standard Time. And in Central Time, they are at 4 and 10. So you're never more than 6 hours away from a new track forecast and new probabilities. Remember those intermediate advisories that come out 3 hours afterwards? Those update the position. If watches and warnings are in effect, that also means they can change the definitions of the watches and warnings, but the forecast track itself doesn't change every 3 hours, it changes every 6 hours. So let's say we are in the situation, we're waiting for that 5 p.m. advisory and clicking refresh. Well, you don't have to click refresh in HURREVAC because our system is designed to pull the NOAA servers and bring those files in and interpret them and map them just as soon as we see them. So there is a range of time when you can expect to see products leading up to the advisory hour. The advisory hour being that 5 p.m. But as you're checking, there can be times when you may see information as early as 20 till the top of the hour, or 45 past, 50 past. Certainly within the few minutes before the advisory hour, that is the goal for getting that disseminated. And the first things you'll see are the text-based products. So that means the track points, the text advisories, the discussion, and also the wind speed probability points. And also at that time, you can run the deterministic wind timing report because you have that wind radius that's defined by the text product. The times vary, especially when there's multiple storms out there, and you may see one storm come first and then the update to the next and the next. Remember, what we just talked about, those are not updated at the intermediate advisories. And if it was that advisory hour, it's 5 o'clock, we've got the new track, we are seeing the updates there, and you go to run your wind timing report for a location, and you're looking for that probabilistic time of arrival, the earliest reasonable, the most likely. In that moment, you are likely to see TBD because that report is reminding you that some of the advisory products have come out. The others are just minutes away. That probabilistic information filters in usually just after the top of the hour. And so during that moment, you will see that TBD result. It means to check back very soon. The potential storm surge flooding, which is a probabilistic product, that is also something, if you go to check it at that moment, you're going to get a pop-up that says it's not available, but it is on the way if there are storm surge watches and warnings in effect for the US. What happens next? 5 minutes after the hour to about 10 minutes after the hour, 15 at the very latest, we see those probabilistic layers and data sets come in. And so that enables you to run probabilistic reports, your time of arrival, your time of departure. And that means the evacuation timing report can be run, which we will learn about today. And by that point, you should have the outlines for your watches and warnings, and also the peak surge graphic if it's that kind of a situation. The only thing at this point that you don't have, let's say it's 5:15, the only thing you're not seeing is still the potential storm surge flooding. As we learned yesterday in our presentation, this process for generating that map down at the NHC Storm Surge Unit, that starts when this advisory comes out. So they are running those computations. They are evaluating it and processing it and putting it on servers. And so about 60 to 90 minutes is the general advice for how long that takes after the advisory hour, which means if we were talking about 5 p.m., that'd be 6 to 6:30 p.m. And I would advise coming in at maybe about 5:45 into HURREVAC and just checking to see if it's there. Sometimes it can be a little bit sooner, but certainly make a point as part of your rhythm of when you are checking things in HURREVAC to understand that the time you check does make a difference in terms of what's available. It is time to switch over to my HURREVAC workspace in my web browser. And I just logged in. And as I've done the past few days, I want to recap what we see when we log into HURREVAC. Yesterday, we had an active storm, Tropical Storm Arthur, and that has since dissipated. But we do have activity on our tropical weather outlook now. The non-tropical storm strength remnants of Tropical Storm Arthur, currently located over Mississippi and Louisiana, bringing very, very dangerous and heavy rain, is still being tracked as something that could potentially redevelop off the eastern coast of the United States, east of North Carolina or Virginia. So the X tells us where the disturbance is now. The shaded region tells us where the formation could occur if it was going to occur. And the color, like the legend down on the bottom, tells us the likelihood of it. So it's a less than a 40% chance. One way to learn about what's going on with that specific disturbance is to click on it to read the text product from the NHC, or you can expand the tropical weather outlook window to get the longer version. And here we see our probabilities of formation through both 48 hours and the next 7 days are 10%. Now, there's information not only for the Atlantic, Eastern Pacific, and Central Pacific basins, but there is also a tropical weather outlook issued by the Joint Typhoon Warning Center for the Western Pacific region. And at the time of this broadcast on June 18th, there's a high likelihood of development in the areas near Guam and the Northern Mariana Islands. So that to track that in HURREVAC, it is the fourth tab once you expand the tropical weather outlook window. I'll close out of that, which clears that layer from the map. And since we don't have any active storms anywhere in the world at this point in time, HURREVAC is essentially blank for us. Before we go into looking at our hurricane evacuation study materials, it's time for our first poll question of the day, and a pretty simple one. Are you currently located right now, where you're at, the building you're in, are you located inside of a hurricane evacuation zone? Yes, no, or not sure? We'll give you about a minute to give us your results and then take a look at what you said. 41% of you saying you are currently inside a hurricane evacuation zone. 52% of you say no, you are not. 7% say not sure. Well, we are about to look at the map layers in HURREVAC where you can evaluate this for your community. So thank you for your responses on that. As we've done in the past few days, to make sure that it's easy to get our bearings with geography, I'm going to turn on the state and county boundaries in my resources tab. Counties are going to come up a lot today in our examples and our discussions. So now you have that darker outline around the states. And as you zoom in closer and closer, like I'm zooming into the Georgia coastline here, you see that breakout of the counties and the names of the counties. So my first example is going to be in Georgia. So I'm going to right click in Chatham County, which contains Savannah, and set my base location. So now all of the reports and the storm surge slosh basins and also some of the evacuation timing tools instantly know that the information I want to access most quickly is the one that pertains to Georgia or Chatham County, Georgia. And while it's not necessary to set a base location before looking at the HES materials, since we're in the Resources tab, I'm going to show you where the directory is that contains a lot of those documents. Go down to the library, which is the very last folder in the list, and then open the subfolder called HES Documents. And you see a link for all the states and some territories as well. And we click on Georgia, and that opens a new tab in my browser with a simple download directory of the PDFs, usually a different PDF file for each chapter of the HES, but each state, this folder, this directory looks a little bit different. They may have other supporting materials, but this is one place to access this information. A reminder, these PDFs can be large and many pages long, so now might not be the best time to download and start reading through that, as your video connection for this webinar might suffer with that large download. So we want to make sure all your bandwidth is going to this demo that we're doing right now. That's one place to access it. I'll show you the other place later on. A quick word about Florida. In most cases, I believe all cases, it will be a link to a website that the state hosts that contains those documents and materials rather than a PDF hosted on HURREVAC. Okay, one of the benefits of setting a base location, the final shortcut, is that it filters down the list of evacuation zones. You see our first folder here below all these checkboxes called evacuation zones. If I expand that, you see a lot of states listed here. If I were to expand any particular state, like Texas here, I see the long list of counties. So instead of clicking multiple times and scrolling, the nice thing about the base location is if I click on this flag in the top left corner of the Resources tab, it narrows down that list just to the county and the state that I'm interested in. And by clicking that checkbox, I have my evacuation zones loaded on the map. Now notice there's no legend for this, just because there's quite a variety of ways that these can be symbolized and named throughout the country. So to see the name, for example, we're going to click on this yellow area right along the immediate coastline, and that is Zone A. In the red is Zone B, and I'm just tapping or clicking on that blue area to get that little bubble that says Zone C, and then I just click anywhere else to clear that bubble off the map. It is possible to turn on evacuation zones for multiple counties, or in fact a whole state, but just be aware if you do that in a state that has a lot of counties like Florida or Texas, the more counties you turn on, the longer it will take for all of that to fully load in. And this is another good opportunity to remind you that to adjust the visibility of this layer so it's best for your screen and what you're trying to do with it, the quick layers options. In fact, we're probably going to use this one or two more times today. This storm tool to the left of the tracking map has a row in it where we can make really fine adjustments to the outline or to the fill of those evacuation zones, because we want to understand, in some cases, what is the underlying geography or land use, and in other cases, we want to understand how those zones intersect with the potential storm surge hazard. So you can see there's two sliders on here, one for the fill and one for the opacity, and that's probably not the last adjustment I'm going to make for the day. You see that we're looking at our evacuation zones. Yesterday, we looked at a lot of surge data, the operational products, as well as the planning tools, the MOMS and the MEOWs. So I'd like to give you some examples of what it looks like to evaluate storm surge data alongside your evacuation zones. Remember, our Storm Surge Slosh Explorer is something we can look at year-round. We get to it down in our toolbox at lower left, and it's the fourth button that says Storm Surge. And the panel that opens from the right lets me look at the MOMS, which is maximum of maximums. It's a composite of all basins and a single worst case scenario for a given category of storm. And what it would look like, say, for category 3, I display on the map. It zooms out to remind me this is a national composite. I use my left facing arrow called Go to Previous Map Extent to move back into that region I just was, and I'm going to zoom in even closer into Chatham County. And here's a little bit of the challenge, and also the way that HURREVAC helps you address the challenge is that we have three colorful data sets going on. We have a colorful base map, we have colorful evacuation zones, and also colorful raster data indicating the inundation above ground for all these points on the map from a worst case category 3. And that's a lot going on. It's kind of unavoidable, but there are some customizations we can make. First, our base maps. Remember, one of my tricks when I'm looking at this map and want more room on the map, I can collapse the left panel. And that uncovers my base map selector, which is in the lower right corner of the tracking map. And the first thing I might consider doing is changing to the light gray canvas. So now the base map isn't adding any color. And another thing I can do, I still have quick layers open from earlier. I have a row here called Mom Surge, and I can move this slider up and down on the opacity to understand, which of my zones, A, B, and C, have a land area that could potentially be affected by inundation from a category 3. And in this case, all 3 of them, but to different extents and different severity. And especially in this part of the country, you might also be interested in looking at the imagery base map, especially if we were more on the neighborhood level to understand where there's streets and land use and various things. That's one adjustment we can make. Let me go back to my light gray canvas. The other, again, is to change the display order and opacity of the zones themselves and maybe reduce the opacity of the fill color, but really make those outlines very bold and put this on top of the surge layer. So now I see the outline of zone A and B and C and look through the fill to see that underlying mom surge data. And there's no one perfect way to do it. We have zones that look so different across so many different parts of the country. And you may prefer different base maps for different reasons. So this just gives you options to make fine adjustments that work better for your situation and your screen. But we want to make sure you know about how to do those adjustments and are comfortable doing so. Why are we doing this in the first place? Well, knowing which zones may be affected by that hazard really could impact which evacuation scenario and which clearance time ends up getting picked as we consider taking an action. Now, a MOM, that is very general. It's combining a lot of hypothetical hurricanes. Let me remove this from the map and show you what this same thing looks like with one of the operational storm surge tools. That would be something associated with an advisory. So I'm bringing out my panel again from the left side, going to the Storms tab, and I'm going to show you an exercise storm called Ella. There was a real storm called Ella in the South Pacific in 2017, but we want the one from the exercise storm folder. This was created by the NHC to support a tabletop exercise. And we do have to scroll forward. These go through actually chronologically. So instead of going to the last advisory, this goes to the first one. And about the point we get to advisory 16, there is some potential storm surge flooding data for this exercise storm. And if I zoom back in to the coast of Georgia, I can now see what it looks like combining this evacuation zone with this potential storm surge flooding data, which has that blue, yellow, orange, red color scheme that we saw yesterday. And I can also go back into quick layers and make adjustments here. The shortcut name for it in quick layers is probable surge, but you see if I really dial up the opacity here and see those bright colors in relation to my zone outlines, that's one way to evaluate both things at the same time. It's interesting though, when we go to look at the option with the tidal mask, almost everything is gray. This is not a footprint, remember. This is a worst case scenario that's still based on probabilities. But there is some worst case scenario that involve inundation in some areas that are normally dry. And so here we've just filtered out all the inundation potential over areas that are normally wet. We come down here just a little bit east of the downtown area and see some of these dry areas that could be inundated. So this is a way you would combine tools in HURREVAC to evaluate that potential hazard. All right, we're going to use a different location and a different storm to continue looking at some examples. First off, you might have guessed where we're headed if you haven't already clicked around. The evacuation timing window is what contains your selections for evacuation scenarios and clearance times. If I open this right now, because I've already just set my base location in Chatham County, Georgia, it already knows that the evacuation scenarios are going to be the ones that pertain to that are derived from that HES. Every state, as Franny mentioned, the HES process is customized and looks a little bit different, and these parameters and these names can look a little bit different from state to state. Note that Georgia here has 7 parameters when filtering through the analysis to get to a single clearance time. We're going to talk about these other tabs in due time through the rest of our session today. But watch what happens when I reset HURREVAC. I'm just refreshing this window. It has cleared Ella off. I get my tropical weather outlook back on by default. I'm going to turn that tool off because we're not focused on that right now. My base location is still set to Chatham County, Georgia, but that little flag went away. That's just a temporary reminder. What we're actually going to do next is look at an example in New England. And I'm going to set my base location out past Cape Cod in Provincetown, Massachusetts. And if you're following along with me, it is the community that is right at the tip of that long cape to the east of Boston, where it curls in. And that is in Barnstable County. And watch what happens when I go now to my evacuation timing window, accessing it from my toolbox at the lower left. All these parameters look a little bit different. Instead of 7 parameters, there are 4 parameters here. Let me get this side by side. If I did want to choose a different county in Massachusetts to access the different towns within them, I could make that selection from this list right here. But a lot of this interface below is grayed out. I have to make selections before I can do much. So let's just work our way from top to bottom through this. And the first thing I'll point out is the link to the technical data report. This is what I alluded to several minutes ago when I said there's a second way to get to your HES documents. One was from the library in the resources tab down here. The other, in the case of most states, is to click on that link in the clearance time window. And then this takes you also to that directory with the PDFs. And that's a place where you can download them or read through. Which again, we're not going to do that right now because our focus is not to make you the expert on any particular state's HES. It is to show you where to find it and how to apply it and how that math works inside HURREVAC when we're making an evacuation timing report. So the other reason that things are grayed out is that we don't have a storm yet. There's really only so much we can do with this in isolation. So I'll go ahead and start by selecting, remember, I made my base location in Provincetown and I've chosen that from the list. And my range of scenarios, the clearance times that are in consideration, until I've made those other selections, it could be as low as 12 hours or it could be as high as 34 hours. So this red text above these lists tells me something about that range. And as I make more selections, that filters down to a single hour in whole numbers. The evacuation zone is the next thing I have to choose. Am I considering evacuating zone A, or what would happen if I evacuated zones A and B? Well, where can I go to evaluate that? My evacuation zones can also be turned on from the resources tab. And I'll zoom in just a little bit more to show you what the geography looks like here. The red is zone A and the yellow is zone B. So for the sake of just getting some numbers on the board, I'm just going to say zones A and B. You just saw what the process looked like, though, for evaluating storm surge data alongside your zones and seeing what that does to your number of hours that are in consideration. So my current range of hours, 18 to 34. The next thing I have to choose is a response, fast, medium, moderate, or slow response. We do have tooltips that if you hold your cursor over the name of that clearance time parameter, it spells out for you what is meant by response. So in this case, it's a fairly long answer, but this is a situation where I will just keep it moving along by choosing moderate. We may have other reasons to go slow or fast in the real world. Our range of hours at this time is still 18 to 32. The final thing I have to select before I can store a clearance time in my profile is seasonal population. Is there a low number of evacuees from seasonal population or high number of seasonal population evacuees? And again, holding the pointer over the name of seasonal population gives me that tooltip that says consideration of evacuation traffic associated with population who visits but does not reside in the evacuation area. So maybe we're considering that this is something in August. It's still peak tourist season. Let's say high number of evacuees from seasonal population. And that gives me a total number of evacuation hours of 32 if these are my considerations. And then to store it in my profile so I can generate a report based off of that clearance time, I have to click Add Scenario. And this selector resets. And now I'm starting to build a list of saved scenarios in the bottom part of this window. And I'm going to go through this one more time just so we have a different one stored that has some different numbers so we can see some variation in the math. So remember, we're staying with the town of Provincetown. This time I'm going to show you Zone A only, and that range of numbers is on the lower end, 12 to 24 hours. I'll stay with a moderate response and high number of seasonal population, and that gives me 22 hours to perform that pre-computed action. Down here in my list below, if I wanted to delete something, I would check that box next to its name and then click delete. Also, especially in areas that have a lot of parameters, it's really difficult to get a full list of text into this window that spells out what all those selections were that gave you that 32 hours. So if you hold your pointer over that row, the tooltip explains in longer form what those selections were that created that 32-hour clearance time. But I still can't create a report yet. This Create Report button is grayed out. Until this has some wind timing results to do the math with, there's really nothing to do with this. Think back to that graphic, that chart we saw at the end of Franny's presentation, moving from left to right. We need a storm forecast on here before we can subtract the clearance time from it. So I'm going to go to my Storms tab and look at the example of Hurricane Lee from 2023. And this is loading to the last advisory, but I'm going to use this menu at the top to quickly jump back in time to advisory 26. And at that time, the potential track area error cone was aimed at coastal New England and also the Canadian Maritimes. But this is not a wind hazard. So if I want to know whether there is valid timing data I can work with, wind time of arrival data, I can look at this graphic here, the tropical storm force wind timing graphic, and look at the most likely arrival time. And anywhere within this black line has a greater than 5% chance of tropical storm force winds over the next 5 days. And that also means there's some timing data for most likely and earliest reasonable. And this is one of these cases where our base location is very much in between these two lines, the one that says Friday 8 p.m. and Saturday 8 a.m. So HURREVAC is using the underlying data to get more specific. A quick adjustment I will make so that this is less confusing. I'm going to open track and swath options to turn off the labels for the forecast track points. So now the only labels on here are talking about the timing of the wind. Also going to collapse the left side panel, zoom in a little bit, and now come back to my evacuation scenarios window. See that the Create button report is now blue, which means if I click it, I will generate a report that opens from the right side of the workspace. In fact, I'll go ahead and close out of this evacuation timing window. And this is our evacuation timing report. In real life, I might have selected different clearance times based on this forecast. The point of choosing these was to give you some examples of how this math is going to work. This is not to suggest these are the choices that would be made in this situation. And just in general, as another reminder, HURREVAC does not tell you if an evacuation is necessary. It doesn't tell you which scenario to pick. It doesn't tell you which assumption to use. It creates a timeline based on the forecast and based on your inputs so that you can have that decision support. We have two rows in the results of this report because I put two different timeline actions into my user profile. If I'd only stopped after I made the first one, there would only be one row in this report. If I'd kept going and was selecting 3 or 4 clearance times because I was trying to discern between different permutations, then I would have 4 results here. But there's a few things I can do to try to make this text larger as we explain what this means. So I'm going to first off collapse the report description. And you don't have to do this on your workspace. You can just watch my screen, but I am doing that Control+ maneuver so that it expands the size of the text. This is really just to make it easier for you to read on this webinar here. But now let's step through this from left to right and talk about where this is coming from and what this interpretation is. So I have a reminder of my location. In both cases, it's the same, but I have different evacuation scenarios under consideration. And as we saw a second ago, 4 different parameters went into this. So if I want to remind myself what those parameters were, I get a tooltip if I hold over the row in this column that says evacuation scenario. And just skipping ahead to this middle row with the white fill that says clearance time or action time. The first row is 32 hours. The second row is 22 hours. So those are the variables. That's the input that we put in just a second ago. These rows with color, the light blue and the medium blue fill, those inputs are coming from the forecast from the NHC. At this time, it's 5 p.m. on Monday, September 11th, 2023, Advisory 26 of Hurricane Lee. What is the earliest reasonable time that the wind could arrive in our area? 7 p.m. on Friday. And the reason it's the same for both is because we're evaluating the same county, the same community in both of these clearance times. If for whatever reason we'd put in clearance times for a county or a place in Massachusetts and then another one in North Carolina or Maine or wherever, you would see differences in these times. But as long as it's the same town or county or parish that's in consideration, these columns are going to say the same thing. So now let's do some math. Our earliest reasonable onset of tropical storm force winds, remember that is our more risk-averse planning assumption. That's saying there's only a 10% chance that the tropical storm force winds would start any earlier than Friday on 7 p.m. So if I'm not willing to take a lot of chances and really want to create as big of a buffer as possible, that might be a clearance time, or that might be a planning consideration I would use when I subtract this clearance time. But I don't have to do that math. HURREVAC is doing it here in this report. Let's see what it looks like to subtract 32 hours from Friday at 7 p.m. If that's the basis, if that's my planning assumption, then the earliest time to initiate that action or to have made a decision to initiate that evacuation is 11 a.m. on Thursday. And likewise, with the darker blue row, this refers to the most likely onset of the tropical storm force winds, the statistical midpoint of all those various scenarios that are run by the NHC. Subtracting 32 hours from 1 a.m. on Saturday takes us to 5 p.m. on Thursday. So between earliest reasonable and most likely, that's an 8-hour difference, or rather 6-hour difference, excuse me. And so that's also true in terms of these start times, 5 p.m. versus 11 a.m. on Thursday. And the question is, do we still have time to initiate this action? And the answer is yes, because it is 5 p.m. on Monday, and these evacuation start times based on these inputs are out on Thursday. So there is time to evaluate later forecasts and see how it evolves. There's also a column on the right that is the tropical storm force wind probability for that county. It's at 25% here. So with the 22-hour clearance time, I imagine I have even more time to consider that, and that's the case here. 22 hours subtracted from Friday at 7 p.m. takes me to Thursday at 9 p.m. And 22 hours subtracted from Saturday at 1 a.m. gives me Friday at 3 a.m. And HURREVAC is just doing this math. There are real-world reasons why an evacuation might not be called at 3 in the morning. This is, again, pulling together this forecast information and combining it with your pre-computed inputs, but there's other factors to take into consideration when making decisions about evacuations and factors that may be outside of what you can show in this report here. So this is a starting point. Once this window is already open, you can also create the evacuation timing report from this list. So one way to start making this report, as I kind of reset my workspace and zoom back out, I had my evacuation timing window open and I clicked this button to create the report. If I was dealing with the same set of clearance times in my profile and didn't feel a need to modify them day over day, I could just come into HURREVAC, and as long as I had a storm turned on, I could go to the reports and click create report and click create evacuation timing report. And that would get me the same information. It's just two ways to get to the same report, but know that those are both options available to you. These earliest reasonable and most likely when time of arrival should look familiar, because this calls back to what we were doing on Tuesday when we made a wind timing report. It's the same numbers you would see there. In fact, if I right click and create a wind timing report for Barnstable County, Massachusetts, which contains Provincetown, we have our earliest reasonable time of arrival of tropical storm force winds, 7 p.m. And that's the same thing that we're seeing in this first light blue column right here. Most likely, and so forth. There was a question a couple of days ago we said we would come back to when we had some time, which is talking about the resolution of this. It would not show us a lot of difference, for example, as I said, if we placed wind timing flags in several places within the same town or the same city, because the density of this underlying data is not so high that you would see meaningful differences across a single county. But for counties that are very large and spread out, that's where it does make a difference where you click and where you make your assumptions, because it may be in a different grid cell that has some earlier values and different times. So a quick visual demonstration of the approximate size of that. Again, you don't have to do this, but just watch my screen. I'm going to go to map settings to turn on the latitude and longitude display and show the tick marks. And I'll switch to the classic base map where it's easier to see them. These lines of latitude and longitude are at 5 degrees. So here's 65 west, 70 west. And then these tick marks are for 1 degree of latitude and longitude. So this is 41 north, 69 west. This probabilistic wind data is on a half degree grid. So using my drawing tool, this is 1, 2, that's whole number. And then half degree is like this. And not doing the best job with my longitude, but you get the idea, the approximate spatial resolution there. So the answer I couldn't quite access mentally the other day was trying to translate this into terms of miles, because that answer is different depending on how far north or south you are, just because of the way that it works being on a globe. But anyways, that is hopefully a helpful bit of context on what is going on with that. And let me reset things just a little bit on my tracking map and also remove those tick marks so we just have the lines only for latitude and longitude. And one other thing to note when we are dealing with these clearance times, again, these are pre-computed. If I go back here into my evacuation timing window, this information, these selections, these are not by themselves changing dynamically based on the forecast. What you choose to select could be different based on the forecast. But when we go to this evacuation timing report over here, if you don't choose to change your clearance times, those would stay the same. But what would change with a new advisory is this onset of wind, and that could update, and it could get later, or it could get sooner, or we could see a larger difference between the earliest reasonable and most likely. So let's see what it looks like when we go to a later advisory. I'm going to jump ahead to advisory 34 5 p.m. on Wednesday, September 13th. Actually, rather, let's go to 33, 11 a.m. and click Update. And there I get some new values for 6 p.m. earliest reasonable time of arrival, 5 a.m. for Saturday. And I'll just zoom in briefly so you can see that zoomed in. Clearance time hasn't changed, just the wind forecast. This is one framework for understanding the amount of time we have to make a decision about performing an action. This is the probabilistic framework. Going back to what we were talking about the other day, this is based on a lot of different simulations. Most likely is that 50%, that midpoint. The earliest reasonable is the 10% chance that it would happen any earlier than that. What if we do want to look at this with deterministic tools? Well, let me close out of that report for a minute and go back to my tracking map and reset a couple of things. Turning off the time of arrival graphic, turning my track labels back on, and I'm also going to show the size of this hurricane's wind field. As of advisory 33, located south of Bermuda, but still forecast to be moving north to the east of New England as a Category 1 hurricane. And I can look at my deterministic wind swath, which in 2023 went out to the 3-day range. Now it goes out to the 5-day range. But even at this time, advisory 33, this deterministic forecast shows my location is inside the forecast wind field by day 3 of this forecast. So there's a map-based tool we can use. It's called timing arcs. And so it can still be based on a clearance time we've selected, but it looks at the movement of this wind field to make its calculations. And let me show you an example of that. So I'm going to turn off this swath, but I'm going to keep the forecast wind field, or the wind rings, turned on, and go back to open my evacuation timing window again. Move that to the right, move that to the left, close out my left panel. Just making some slide adjustments so this should be easier to see on the broadcast. And I'm also going to introduce a new tab in the evacuation timing window. So we started with the one on the left that was evacuation scenarios. This is where I entered the clearance times. The middle one is timeline actions. We're coming back to that before the hour is out. Going to the right side, timing arcs. Timing arcs are graphical depictions. It takes the average forward speed of the storm and multiplies it by the number of hours in your clearance time to arrive at a visual distinction of when you need to complete your action. Or initiate your action so it can be completed in time before the hazards arrive. So to get that showing up on the map, notice anything I have saved in my evacuation scenarios is already populated down here. To make the timing arc show up, I need to click the checkbox in the show arc column. I'm going to start with the one for this 32-hour clearance time. And I'm also, well, this may be a case where turning the legend and collapsing it at the bottom can allow us to sort of see everything. All right, we're going to start with just one timing arc on the map, and then I'll show you what it looks like with 2 timing arcs. If I hold my pointer over the edge of this arc, this purple circle that is swept out from around my base location, that explains to me the selections I made in the evacuation scenarios window to get to that 32-hour clearance time. If I just need a reminder, again, if I'm considering multiple things. So now, moving this deterministic forecast forward along its track, hour by hour, the time at which it touches this arc is the time that we need to start that action or consider making a decision about doing it. And that is 33, 34 hours from now. So that is 9 p.m. Thursday, September 14th. This is the deterministic way of answering that question. So we would need to start that evacuation, if these are the choices we're making to get to that clearance time, by 9 p.m. if it's going to be complete by the time the wind hazard arrives. The interesting interesting thing about this is the size of this arc is dynamic based on the forward speed of the storm. So a very slow moving storm means you have a smaller arc. A very fast moving storm means you have a larger arc. It means you have less time. It kind of makes sense that way. So again, this radius of this arc is determined by multiplying the number of hours, which is 32 here, by the average forward speed of the storm. And that's how it gets this number of miles. So here, using my drawing tool, that is 451. So 32 times 14 is roughly 451. This does assume a direct hit. So again, this is a deterministic, not a probabilistic. It does not take uncertainty into account. And especially with a storm that is large and getting larger, that's also something to take into account because that can compress your timeline. And that's why Lee is an interesting example to look at here, because Lee was an example of a storm that was larger than average. In fact, I picked this because if we go into the forecast discussion, which I have to hide some of my windows here. This is where the NHC noted that the wind probabilities beyond 36 hours were likely underestimating the risk of those winds occurring because the forecast wind field is considerably larger than average compared to the wind field used to derive that probability product. Again, that's what was said in the moment there back in 2023. But to see that consequence of a large and expanding wind field in the timing arcs method, if I just click forward along these advisories to advisory 34, 35, 36, 37, notice how the size of this timing arc expands. It's larger than it was at advisory 33. So the size of the wind field getting bigger and bigger is something that can also start to eat away at the number of hours you have to get ready before the winds arrive. The other thing that would do it is if the storm is forecast to speed up along its forecast track. So at this time, it is now 11 a.m. on Thursday. We haven't even moved the storm forward on its forecast track. This is the 0 hour. This is the advisory hour. With this forecast wind field selected, it's already touching this timing arc. Basically, at this time, we're out of time. If we're going to get hit by it, it's tropical storm force winds. They are already within 32 hours of reaching us, according to this deterministic tool. So they both have their interesting ways of looking at it. And these are both things you can evaluate, or you might find based, again, on your preference or your type of operation that you gravitate to one method of calculating your evacuation timing or the other. But I would just say that knowing and being comfortable with the evacuation timing report allows you to evaluate that earliest reasonable and most likely and see what that does. You can also have this timing arc turned on by default every time you open HURREVAC. Let's say this is a situation where you're following the same storm every shift through the course of a week as it approaches, and you don't want to go through the steps of logging into HURREVAC, turning the storm on, which should be on by default anyways, and then clicking into this window and clicking this checkbox to show the arc by default. You could just go to this button called Save Arc Selections, and now whenever you turn a storm on, you'll already see your arc. I would just say a note of caution, it will show an arc for storms that are, it could be anywhere and that might not be a threat whatsoever to you. It's just doing that calculation based on what's available. But if you are in a situation like this and you know that this is the storm you're tracking and it's a threat to you, this could make a lot of sense and save you some clicks every time you open the program. It is also possible to turn on multiple timing arcs. And I've done that by clicking this checkbox for the row for the 22-hour clearance time. And if this was also another action that I was considering in this moment, the 22-hour clearance time is still something that I have time to execute because this blue wind field is not yet advanced forward and intersecting this timing arc. Let's see what time that would be. Advancing forward hour by hour using those up arrows. We get up to about 12 hours, 13 hours out before we are within that time frame. It is also possible for you to have timing arcs in different locations, as we're going to see an example of later on. And you can also have timing arcs not just for your clearance times here, but you can do timing arcs for any custom action that has a number of hours offset before the wind arrives. And that's the timeline actions, which we're going to get to shortly. So it will be interesting just to go back to that evacuation timing report and update it for advisory set 37. Or actually just step back to advisory 33 here on the map and see what are the differences between this deterministic and this probabilistic product. So let me go back to the point in time where our 32-hour clearance time. So our storm is at this position at this time. When it touches the timing arc, that time is 9 p.m. on Thursday, September 14th. And it so happens that is the same readout as the most likely time of arrival assumption. Sometimes they will align that way, sometimes they won't. But knowing how these work and the caveats associated with them allows you to make that informed comparison. We're going to do a little bit of review from yesterday with another poll question for you. Which factors affect storm surge? We saw that presentation at the beginning where we saw some examples of how these variables may affect the severity of storm surge. Storm intensity, forward speed of storm, angle of approach, shape of the coastline, or all of the above. It is almost unanimous. Yes, all of the above. Storm surge is affected by a lot of factors, including the category of the storm, how fast it's moving, the angle it hits the coastline, the location it hits along the coastline, the shape, the bathymetry of what the continental shelf is like. If you want to review all of that, be sure to, or if you weren't able to make the first part of yesterday's webinar session, be sure to check out that YouTube video with our presentation from Cassandra Mora at the Storm Surge Unit at the NHC to really get some good visualizations about all of these factors and how they affect the severity of storm surge. So on that note, I want to talk a little bit about Hawaii, because going back to Dr. Brennan's presentation on Monday, we got our update about the NHC product changes for the year. And one of them is the expansion of surge products to the Hawaiian Islands, the peak surge graphic, the potential storm surge flooding map layer, the surge watches and warnings. And I want to show you some examples of what that could look like. We hope it will not be necessary, but we expect that those products would be in HURREVAC. And there is an example storm, an exercise created by the National Hurricane Center that incorporates some simulated storm surge graphics for the Hawaiian Islands. And the name of this exercise storm, Pilipo, moving up to advisory 21, I want to show you a few examples. And you saw a couple of things if you're paying close attention. I'm using a different HURREVAC workspace where I've already made some adjustments here. I have changed manually my time zone to Hawaiian Standard Time with the 10-hour offset of UTC. I did that in my user preferences. And I've also switched to the classic base map because at a wider view, it just makes labels that stand out much, much better for the islands and the nations throughout the Central and the Western Pacific. So for a lot of our users in that area, the classic base map may be preferred. But as we're zooming in to make a closer evaluation of things like our storm surge layers, we might want to look at something, again, like the light gray canvas to see where that color pops out. So here with the peak surge graphic, this is kind of our regional at a glance view showing the ranges of the peak surge along the immediate coastline between certain points. Doesn't go into a lot of community level detail, but this is, again, on the state or regional level, a quick summary of the hazard and how it varies. And there's also the option to show this without the communication points. We have the surge watches and warnings. which show up the warnings in sort of darker pink color and the watches in the lighter purple color. And if surge watches and warnings are in effect, it would follow that there's going to be these next two storm tools. The potential storm surge flooding is generated, again, within 72 hours of the arrival of hazards. And there's two options here, with and without the tidal mask, which we saw a little bit earlier. Without the tidal mask, this is, in this simulation, this is just an exercise storm, not a whole lot of very obvious inland extent when we're on that wider map view. But as we zoom in just a little bit to these areas, you do see some blue color associated with that data, because we've gone to that gray base map. So we know that any color that is showing up is coming from this data. In fact, there's some pixels at various parts of Oahu of the yellow greater than 3 feet. And if I right click there, I can place that surge flag. I just barely missed that pixel, but you get the idea. And then when I turn on the tidal mask, in this case, it is largely the same. So that is just a quick word about the surge products, a quick review there. We're still going to continue looking at our evacuation timing tools because this exercise storm also has with it timing data, time of arrival of the tropical storm force winds, as indicated by the tropical storm force wind time of arrival graphic. So I'm going to go back into my evacuation timing window and show you another example of how we can do custom timeline actions and also apply our points of interest. Now I am using a different workspace. So if I'd been in the same workspace as you just saw in those past demos, I would want to make sure I go in and change my base location and delete my clearance times. In this case, I've already cleared it out and it already knows my base location is Hawaii. And if you are a first-time HURREVAC user and have been following along up to this point, now might be a good time just to watch my screen, because I will be going in and moving a little quickly as I add points of interest. And it won't be necessary for you to add the same points of interest, but you are welcome to make them whatever you need them to be for your operations going forward. But we're still, again, looking at this exercise Hurricane Pilipo Advisory 21. And I want to talk a little bit about the middle part of the evacuation timing window. We're now in timeline actions. Maybe I'm not concerned with clearance times and general public evacuations, but I do have actions I want to take prior to the arrival of tropical storm force winds. And we hear a lot of examples coming in from our attendees in HURREVAC training of what may be useful, whether it's medical evacuations or checking on fuel or staffing or staging resources, things like that. This is how you can take account for that and make a similar looking report based on those number of hours it takes to do those things. And this is really where you have to provide all of the inputs. So you do need to create a name and a description for what that action is, and also give it a time offset. So for some very easy math, I'm going to do a 24-hour time offset, but I can't make my timeline action until I give it a name and a description. So we'll just call this a test. Now this is going to be based off of Honolulu County. And I'll just give this a description of a 24-hour test and click add timeline action. And now I can create a evacuation timing report as well. This is now highlighted. I have a storm turned on the map. So let me click this button and see what happens. I get a report like we just saw from Massachusetts, formatted the same way, but instead of being based on a clearance time, it's based on this custom timeline action that I've designated as 24 hours. So that's why the column headers in this report have that sort of dual purpose naming to them. Notice one other difference as I try to zoom this in and make it look a little bit bigger, is that in this report, you can have a mixture of both timeline actions and evacuation scenarios. Your clearance times are going to be bold. Your custom timeline actions are going to be in italicized text like this. So let's follow this math again. For Honolulu, our earliest reasonable time of arrival of tropical storm force winds is 6 a.m. on Saturday. This is a 24-hour action. I subtract 24 hours from 6 a.m. That's pretty easy. That's Friday at 6 a.m. And with the most likely onset of wind is noon on Saturday, subtract 24 hours. That is noon on Friday. So where are we at right now in relation to that? This advisory is 5 p.m. on Thursday. We're not yet at that point, but it's getting close. This is based on the outline of that county. And just as we were thinking about with those wind timing reports for counties that are larger than others, like Hawaii versus Honolulu, that can make a big difference in your results in this report. So if you're concerned with a single town or facility, maybe this is more general than what you need. There's a way to get a little bit more specific, and that is using timeline actions based on POIs, or points of interest. That's also a clever way to show how this timing, if you have facilities that are scattered out throughout a region, like throughout the Hawaiian Islands in this example, you can see how this timing differs based on several different locations. And so I'm going to fill in several different points of interest to illustrate that. So let's collapse this report again and zoom back out as I start working on making some points of interest. So I can start by making one here in the Hilo area, and I'll call this location 1. And notice that I'm being pretty general as I place these. I'm not zoomed in and looking at the streets or addresses. I can certainly do that, and I would encourage you to do that if being very specific matters to you. But if not, or for the purposes of something sort of on the regional level like this, this might be an acceptable zoom level. So I was looking for Lahaina there. I'll right click and create another point of interest there and call it location 2. And move to Honolulu and create a point of interest, location 3. And finally, by Waimea, location 4. So now I have 4 points of interest scattered around. We can already tell just looking at this that if the wind is going to affect us, it's going to arrive at different times. We can look at it deterministically by turning on my wind rings and advancing that storm forward. And if this one scenario plays out like this, that tropical storm force wind, and in some cases the hurricane force wind, moves in and out of these locations at different times. So you can do something similar with your evacuation timing report and with your timing arcs, rather with your timing arcs. All right, so let me go back to my evacuation timing window. And sometimes when you're really zoomed in like this, if you have a tall window, it can sort of move some information off the lower part of the HURREVAC frame. So if that's ever the case for you, just zoom back out a little bit and it will all fit again. So I'm back again in the middle tab of this evacuation timing window, and notice that I have 2 options here. I can make timeline actions based off of a geographic location, like a county. And in fact, any county, inland counties as well. It's not limited to coastal counties. The evacuation scenarios are limited to what's in the HES. The timeline actions can be anywhere, coastal or inland, with the caveat that those winds can be an overestimate in inland areas. But my other option here for designating a geographic location for a timeline action is based off a point of interest. And it already knows what my points of interest are. It's pulling it from that list. The other way to show you that list, again, is in the points of interest menu. I go to the map marker icon halfway down the right side, click points of interest. And here's my list of location 1, 2, 3, 4. And those show up already in this evacuation timing window as soon as I make them. And this might be a reason why designating type can be a shortcut to me. If that was important, I could select type to kind of quickly get to the locations I was considering. But in this case, they all have the designated type of other. So I'm going to start with location 1, and I'm going to make a 24-hour timeline action centered on each one of those points I just made. And again, good time to just watch my screen and watch me do this clicking so we can get through it, and then explore this in your own workspace later on, because we don't want to move too fast or get lost, but this is just going to be a little bit of repetition. So let me remove this last timeline action that was based on the outline of Honolulu County. So we're starting with a blank slate again. And I'm going to call this location 1 test with a 24-hour offset based on point of interest called location 1. Now I'm going to select location 2, and I'm going to call this location 2 test. And notice it actually keeps all the other fields pre-filled, so I don't have to tell it 24 hours again, assuming I want it to be 24 hours. Maybe there's something I want to do by 24 hours before the winds arrive at these 4 points. Location 3, select that from the list at the top. Change that title to location 3 test, keep it at 24 hours. And then so on with location 4. And these are now stored as timeline actions. So I can create my evacuation timing report again. And zoom in a little bit and collapse the description. And now look, this is different than the last time we ran this. Previously, when we had multiple listings, like in Massachusetts, they were for the same location, so the time of arrival of the wind was the same in every row. Here, the time of arrival is different in each row because we have different coordinates we're talking about. So the earliest reasonable time of arrival ranges from 3 p.m. Friday at location 1 to 10 p.m. at Lahaina, 3 a.m. Saturday at Honolulu, 1 p.m. Saturday in location 4, and so on with the most likely. So see what this does. This is the report-based way of analyzing this. And just like the other reports we saw on Tuesday, you can export this from HURREVAC by clicking the export button and copying and paste this and putting it somewhere else you need it to go. Or again, if we were more inclined to look at the map to make this assessment, I can use the timing arc method. So I have to go back to open my evacuation timing window and go to the timing arcs tab on the right. And again, anything saved in my timeline actions is already going to show up here pre-filled as an option. And I can click show arc for location 1. And I'll just go ahead and point out that as of the time of this advisory, 5 p.m., that wind field is already touching our 24-hour timeline action. So for location 1, we're roughly 24 hours away from the arrival of the hazard. So time is up for doing that 24-hour action. For location 2, which is now showing up with a purple arc, and if I ever need to remind myself the difference between the name, location 1 in the blue arc, hold my pointer around the edge of it, location 2 in the purple arc, turn on location 3. It's moving these colors around just a little bit as I continue to add them on, but this is how it's differentiating. The other place where it's labeled is in the legend, which is starting to stack up quite a bit because I have a lot of rows now. So I'm going to collapse that again because we don't really need that right now. And I have all these arcs turned on, and I'll close out of this window. And now this is the way, using this deterministic forecast, I can move this wind field forward along the track and see at which time it starts to intersect with that arc. So location 1, it's already that time. The decision time for location 2 is 12 hours from now at 5 a.m. on Friday, May 1st. It's not when the wind arrives, that's when the wind is approximately 24 hours away. And then moving forward to location 3, that's about 18 hours out. 11 a.m. Friday, May 1. And then for location 4, 26 to 27 hours out, 8 p.m. on Friday, May 1. So again, this assumes that this one scenario of the official forecast is going to play out just like that, and that the storm is indeed going to head our way. This approach doesn't take uncertainty into account, but also it's a good visualization. You can have a lot of arcs on the map, but you see any more than this, it might start to get a little bit harder to see and to interpret. So play around with it. Maybe you are going to go with the approach of having multiple arcs around a single location, or one arc around multiple locations. You can do both in HURREVAC. If I go back to an earlier time, if I want to see how this has changed since 24 hours ago, let's see Advisory 17. Notice that those arcs, slightly different sizes, just a little bit. Hasn't changed dramatically, not like we saw with Lee, but again, as the forecast forward speed of the storm changes, the size of the arc changes too, because this is drawn by multiplying those number of hours by the average forward speed of the storm. So now that we have seen a demonstration of both of our methods of doing evacuation timing, the report or the timing arcs, it's time for our fourth and final poll question of the day. Which evacuation timing tool takes uncertainty into account? The evacuation timing report or the timing arcs? And let's take a look at our result here. And this is pretty much an even split. We've got 51% on timing arcs, 49% saying evacuation timing report takes uncertainty into account. And let's investigate this in HURREVAC to get to that answer. We are looking for evacuation timing report. That takes uncertainty into account because it's based on the probabilistic products from the NHC, the earliest reasonable, the most likely, and its origin is in running the official forecast with a bunch of different variations to see how it could be different. Whereas deterministic is just this one scenario. It's just taking this forecast track, it's moving the wind field forward along it. It's not deviating left or right or faster or slower or bigger or smaller. It's just saying, if this one scenario plays out just like this, this is when the wind would arrive. That's what deterministic means. So when we're looking at the timing arcs like this and evaluating this wind field, this is the deterministic forecast. So this is not showing us earliest reasonable. It's not showing us most likely. It's not taking any uncertainty into effect. It is assuming that this hits us like this. The corresponding map layer for probabilistic products is this tool right here, the tropical storm force wind timing graphic. And you can see why it's not so compatible with the timing arcs. But the evacuation timing report, especially when we are designating our points like this, is the way to get us to that information. And what's also not compatible is having the track labels turned on when we're looking at this graphic right here. So let me do a little bit of recap from the other day. Since we've got some points of interest here, if I wanted to use these as wind timing flags and label this map very quickly without right-clicking in 4 different places, I can change the type of this point of interest from other to wind timing flag. Remember to click update. And I'm going to quickly repeat this action for all of these 4 points. And so now the type is listed as wind timing flag. And it's not important that I have this checkbox turned on. All this is doing is telling me the dot, the location where it is. I can even have this turned off. What I really want to do is right-click inside this data, place wind timing flags, and then load POI wind timing flags. Look at that. Now I have labels for each of those points. And so maybe it didn't save me a lot of clicking today, but if those are my 4 points, my 4 facilities that I'm concerned about, I can go into HURREVAC every shift, every day, load this forecast, right-click, place those flags, and it's a quick shortcut to quickly label this graphic beyond what you're just seeing with these lines right here. So bringing the legend back on, this is most likely arrival of tropical storm force winds. And based on this tooltip, remember, that is the less than 50% chance of earlier onset. That's in the middle of all those different variations that are modeled. And so this is one of these cases where a point near the line right here on it's Friday 8 p.m. And then our point here at Lahaina between Friday 8 p.m. and Saturday 8 a.m. Does line up pretty nicely. It says Saturday at 2 a.m. And then we've got a little bit of collision of text here near Honolulu, but this is in agreement here with this data point saying Saturday 8 a.m. and this line saying Saturday 8 a.m. And if I go to the other option in the tropical storm force wind time of arrival graphic, the earliest reasonable arrival, this tooltip is reminding us this is a more risk-averse planning assumption. This gives more of a buffer if this is the planning assumption we choose to use. This means there's only a 10% chance that the wind would get there any earlier than that. And these happen to be light blue dots that are almost the same color as our ocean background here. So let me make a quick tweak so maybe it's easier to see the color of that dot. And earliest reasonable time of arrival, again, from east to west, going Friday 1 p.m., Friday 7 p.m., Friday 11 p.m., and Saturday 8 a.m. Where do we see those numbers again? In that evacuation timing report. Let's look at it side by side. So location 1 here near Hilo, that wind timing flag, Friday 1 p.m. for our earliest reasonable arrival, that is saying the same thing as this first column right here for earliest reasonable tropical storm wind onset. Then we see 7 p.m., 10 p.m., 7 a.m. It's going to agree with these points on the map by and large. Switching to most likely, again, 8 p.m. in agreement there with that point right there. And so this is the probabilistic way of looking at it because it's taking uncertainty into account. And that's the difference between the two. All right, with that, we are getting close to the end of our time here today. And we want to make sure to, on the way out, let you know about some important things. The resources we have for self-paced HURREVAC training. If you want a refresher later in this season, or at any time, or again, have other team members who are not able to join us on this webinar, here's everything that's available to you, depending on how you like to get information. On HURREVAC.com, we have our webinar recordings, and we also provide the slides. As the program changes, as we incorporate new data from the NHC or different functionality, we make announcements, and that's where you can keep up with what changes in the coming months. And there are also reference guides that are handy, like printouts for your desktop. There's one that's the workspace guide that you saw in today's handouts from this webinar. There's also a longer form version of that called the quick reference guide. It's about 18 pages, and that's sort of like our mini documentation. But the really thorough documentation is the HURREVAC user guide. That's inside the program after you've logged in. You click that question mark and you can search it, and there's a glossary, and there's also a change log of announcements that's telling you what's new. And also inside the program, let me bring it back up for a second and show you the toolbox at lower left. There are training modules. Now, if you've been with us through this webinar week, you've probably gotten all of the content that you would get from these training modules, but this is a good starting point for new users. And this walks you through tutorials while you're inside the program, and you can click and follow along with it. We also recommend the decision-making worksheet. And there's also the HURREVAC YouTube channel. That's where our webinar recordings are posted. Also, a couple of other short topics. There's a quick guide to HURREVAC, so kind of a just-in-time training offering is these shorter topic-based HURREVAC videos that let people get up to speed with only about an hour's worth of time. At this point in time, pause and see if there's any parting words from the National Hurricane Program before we send you on your way.
Thanks, John. This is Franny. I wanted to say again to thank you to everybody who was able to join us for the past 4 days. And a big thanks to all of the folks behind the scenes that are doing a lot of the work and answering a lot of the great questions that we received. Thanks again, and hope you all have a great day.